Today we're going to talk about factoring. We've been talking about factoring while taking out the greatest common factors from our terms if we have a monomial that can come out of all the terms. So the very first step that we're going to do is look for that. If we can take out a greatest common factor, you're going to do that first. Sometimes, though, we've taken out some and there is still more that we need to do. For example, we still have x's in both of our first two terms. So basically, writing a polynomial as a product of factors, we call this factoring. And here are the steps on how you do that. So to factor a trinomial in this form, we first want to make a list of the factor pairs of the C term. Then, once we have the factor pairs, things that multiply together to get the C term, we're going to use these pairs to think, how can I get the B term with addition? So what we're going to be doing is using those two factor pairs, add them together to find a sum, to find the B term, the term that's in front of the x in the second term. Then we use the double bubble method to write two binomials and plug in the pair that works. So note, when the C is a positive number, the two numbers that are the factor pairs will have to be the same sign as the B value. When the C is negative, the two numbers will have to have different signs, and you'll kind of see that as we go, but we can talk about that more later if you need to. So let's look at an example. So we're factoring x squared. We are factoring x squared plus 10x plus 16. Well, the very first step says to find the factor pairs of the C value. The C value obviously being the number 16. So think about the pairs that go together to make 16. There are the factor pairs that would be for 16, a positive 16. 1, 16, negative 1, negative 16, and so on and so on. Now, as you get better at this from above, we said that when we have a positive for the C value, but we also have a positive for the B value, this would tell me that they have to be the positive factors only. So we could almost have ruled out negative 1, negative 16, negative 2, negative 8, negative 4, negative 4. So as you get better at this, some of these factor pairs you won't need to worry about. So then the second step says to look for the sum of my factor pairs that gives me the B value. So in this case, the B value is the number 10. So there you have the sum of our factor pairs. 1 and 16 make 17, negative 1 and negative 16 make 17, and so on and so on. Well, obviously the one that we want, which is the B term, the BX term, the B value is the 10. So that would tell me that this one right here, the factor pair positive 2, positive 8, is the pair that we need to factor this trinomial. So the next step says, this is where you're going to now create your double bubble. We have x in the front half of those two separately. Then we would be putting in the two factor pairs that we just determined that are the answers. And this would now be the completely factored binomials from x squared plus 10x plus 16. Now, one of the things we should always think about doing is also checking. If I do a check on this, I would use that FOIL method that we learned about. And if I do x times x for the first terms, I would get my x squared. If I did the two outside terms, I would get x times 8, which is now 8x. If I did the inside terms, I would get 2 times x, which is 2x. And I did the last terms, I would get 8 plus times 2 is 16. I can combine the 8x and the 2x to verify that we get x squared plus 10x plus 16. So that would tell me that this is the correct answer, the factor of x squared plus 10x plus 16. Now moving on to the next one. So on the next one, we now have the same idea. We're going to be looking to do factoring x squared minus 8x plus 12. So again, let's find our factor pairs of the number 12, and then we'll figure out where we go from there. So there you can see my factor pairs of 12. Again, these have to both be the same signs because the number 12 is positive, so that's the only way I can make it with the same signs for our factors. And then we need to look at the sum. Now this time the sum, we need to be, the b factor is a -8. So looking for our factors to get to that -8 sum, I really should only be worried about the negative pairs because 1 and 12 is a +13. -1 and -12 is a -13. 2 and 6 is 8. -2 and -6 is -8. -3 and -4 is -7. And the 3 and the 4 is a +7. So the pair that we need is right here, the -2 and the -6. Again, the factors that are, the factor pairs, when you add them up, are going to help us equal the b value. So then I do my double bubble. And again, we're doing x squared. So there's a 1 in front of the x squared. We just plug in the two pairs from the factor pairs that we found out. And then we just do a quick check to make sure that that works. Again, first terms multiplied gives me x squared. When I do the outside terms, I get -6x. The inside terms is a -2x. And the last terms would give me a 12. When I combine the -6x and the -2x, I get -8x down the middle. And I get x squared plus -8x plus 12. So that would confirm x minus 2 times x minus 6 equals the x squared minus 8x plus 12. Next we have x squared plus 4x minus 21. Again, our first step really is to see if there's any greatest common factors, but there is nothing that would come out of all three terms. Then I can focus on our steps for factoring this trinomial. So we want to make our factor pairs of the -21, and then we're also going to be looking for the b value this time to be a positive number. So your factor pairs of a -21 are the following: 1 -21, -121, 3 -3, -3 7. Now this time when we do our sum, this time the sum needs to add up to a +4. So as we just go through our sums, we get -20, that's not going to work. We get +20, that's not going to work. We get a -4, and then we do get the 4 that we needed for this pair at the bottom. So again, when we go to our binomials, we do our double bubble, we have the x in the front, we are subtracting 3, and we are adding 7 in the back. And again, when you do your FOIL check, you get x squared plus 7x minus 3x minus 21. And when you combine the like terms down the middle, you get the 4x minus 21 to verify that this is the correct binomials that are factored out. Now, one of the questions that might come about is, does it matter if it is x plus 7 in the first binomial, x minus 3 in the second binomial? No, it does not matter at all. We just want to make sure that we get something down factored as far as we can. And now remember, after we've done these factoring parts, if these were asking us not just to factor, but to solve an equation in this form, remember, we would make sure everything got to one side where it would equal 0, so the other side was completely empty. And then once we had these two binomials, remember the zero product property would allow us to take each one of them and set them equal to 0 to find out what the roots or the solutions to the problem were. This is just showing us how to do the factoring part. If you were asked to solve the equation, that's when you make sure you have everything equaling 0, and then you make each binomial set to 0 to find out what are the roots to the solution. So here we have a problem where we are looking at a rectangular pumpkin patch in the northeast corner of this square plot of land. The area of the pumpkin patch, which we are being told is 600 square meters, so that's something that we want to make sure we are aware of. We want to also know the area of the square. We want to know what the area of the square plot of the land is. So there's a couple different things. We have a rectangular little plot up here in the upper right hand corner. We want to try to figure out what this is going to look like as an equation to then figure out where we go from there. So we want to know what is the area of the square plot of land, which is obviously the big part here. So obviously the whole square is around the outside. That's the part of the bigger piece. And then what we're doing is the area of the pumpkin patch is just this little part in here. So we kind of got to figure out what are the little pieces that are going around this outside to see what we can kind of come up with. Okay, so if I look at the upper piece, it is 40 meters, and the remaining piece of that upper corner, I don't really know right now what that is, this piece right here. But what I can do is use this down below to say that this piece right there is actually S minus 40. So hopefully that makes sense, that S minus 40 would be that upper piece there. On the same idea, if I'm looking at this over here, this whole thing is S meters. Over here, this first piece is 30. So the remaining piece over here must also be S minus 30 to give me whatever that piece is in that upper part of the rectangular pumpkin patch. Now we know that the pumpkin patch is 600 square meters. So because they're talking about area, we know that that's length times width. So I'm going to start this out with S minus 40 times S minus 30. And I know that those two things multiplied together give me 600. So we're just kind of starting out with an equation and see where that goes. Now we have to get this solved. So like I said before on the last side, this has to be equal to 0 before I can use the zero product property. I can't just subtract 600 over because right now I've got a bunch of groups that are kind of put together. So my very first step here is actually to go away from the factoring and put all of this together. So I get S squared minus 30S minus 40S plus 1200 equals 600. So I first have to expand out those two binomials and their product to figure out what I can do with this 600. So what I can do next is we're just going to combine the S squared. We can do the S's together to get minus 70S plus 1200 equals 600. And now this is where I need to get that 600 moved to the left to create a 0 on the right-hand side. So simple order of operations, we do the inverse and subtract 600. So once we do this, we can draw the line. We're going to get S squared minus 70S plus 600, and that equals 0. Now we're right back where we started on the front side, where we have no greatest common factor to take out of that trinomial on the left. We can now focus on the factor pairs of the number 600. Now it's a positive number, so I know that both signs of those factor pairs are going to be the same, either both negative or both positive. But the fact that we are trying to find a sum of a negative 70, that now tells me that I need to find factor pairs that are both negative. So I can eliminate all the positive ones and just focus on the negative ones. Now, obviously, there's a whole lot of them for 600. I think if we really think this out a little bit more mentally and try to use our number sense, we can kind of come out with a little bit better answers. I need to get to the number 70, and I think if I just focus on negative 10 times negative 60, I would get that positive 600, and they would add up to get me the negative 70. So that's the pair that I need. So then I can make my double bubble to equal 0. I'm going to have S minus 10, and I'm going to have S minus 60. So that gives me the look for that, where I can now use this zero product rule and try to go from there to slide this up a little bit to figure out what are the S values. So if I look at this, that would tell me that S minus 10 equals 0, S minus 60 equals 0 would make this equation work. So by solving this, I get S equals 10, I get S equals 60. All right, now, if I go back up into my picture here, we want to look at the numbers that we have in front of us. So if I look at S equals 10, so if S equals 10, which is right here, is that a possibility? Is that something that would even make any sense? And the answer is no, because we already have 30 on this side. Same thing here. If S was a 10, can't possibly be 10 all the way across if it's 40 for this part right here. So what we're going to do in that case is we are going to say s equals 10 is not a valid answer, and we are going to throw it out. Then we look at that answer for the 60. Well, 60 makes sense because if I have 60 all the way across and part of the way is 40 across, that would then tell me that this must be the number 20. If I have 60 going across this way, that would make sense because 30 would give me the other remaining 30 for that piece there. Also, 30 times 20 is 600, which we were told way back that was the 600 square meters for the area of the pumpkin patch. So we're going to keep the 61. And then the question says, what is the area of the square plot? Well, the square plot obviously is s squared is my area. If we know each side is 60, we just have to take that and square it, which means the area equals 3,600 square meters. And that would be the area of the entire plot of land. If you look a little bit further below here, it does give us a little bit of a summary as to what we're talking about, a little bit of a flow chart kind of idea, where you're trying to see the different ideas of the C being positive and the B being positive, vice versa, and all that. Certainly feel free to use that, but I think some of the things we talked about on the front side should help you quite a bit with this. Give it a shot. We'll touch base in class to see how things are going. Please make sure you are working on the activities we're asking you to do, and feel free to bring as many questions as you can so we can really understand how this is working.